This lecture covers 2 more programs on looping statements. First is to design an application to display multiplication table of a particular number. So this is the form we need to design for the application, wherein we have a list box where the table is to be displayed. We have a text box where number can be entered for which the table is to be generated. When user enters the value of n and clicks on the print button, such type of table appears in the list box. Let us see the code required for this application. So we have taken n as integer. N stores the number entered by the user in the text box 1. It will be converted into number and it will be stored in the variable n. To generate multiplication table, for loop is used. For I is equal to 1 to 10. Starting value of I is 1. That is, we are going to generate 5 into 1. If the n is 5, 5 into 1 equal to 5. 5 into 2 equal to 10. In the same way, up to 5 into 10 equal to 50. So we have I is equal to 1 to 10. So as just now we discussed, list box is used to display the multiplication table. In every iteration, one line of the multiplication table will be added into the list box by using the statement listbox1.items.add. And the multiplication table is generated as, if n is 5, it displays 5. Ampersand is used for concatenation, that is to join 5. After that, the symbol star, which is the multiplication sign, is to be added. After that, the value of I, that is 5 into 1 at the first iteration. Then the symbol equal to ampersand n into I, that is 5 into 1 will be calculated and it will be displayed here. Next I is going to increment the value of I by 1 every time. So I becomes 2, I becomes 3, and so on up to 10. So let us understand with the example. If n is equal to 5, I value is initialized to 1 initially. It enters the loop and n, that is 5 into multiplication sign I, that is 1, equal to n into I, that is 5 into 1, that is 5, will be added into the list box. Then next I increments the value of I by 1, it becomes 2. 2 has not reached 10, so again it executes this statement which will add 5 into 2. N into I is equal to n into I, that is 5 into 2, 10 will be displayed. Next I is incremented, it becomes 3. It adds 5 into 3 equal to 15, and so on. It continues up to I equal to 10, that is 5 into 10 equal to 50. This is how the program is executed and the multiplication table of the given number is generated or displayed into the list box. Let us switch to Visual Studio and execute this program. So this is the form which is designed for the multiplication table. Double click print button to write the code for this. So the code is added here, which is required to generate the multiplication table. Once the code is added, next step is to change the startup form. Startup form is selected as table. Click on Start Debugging. So here it displays the interface for the multiplication table. Let me add the input as 5. When print button is clicked, it generates the multiplication table into the list box. Let us take another example. The next example we have is to check whether the given number is prime or not. So prime numbers are those numbers which are divisible only by 1 and itself. Such numbers are called as prime numbers, such as 1, 2, 3, 5, 7, 11, 13 and so on. So this application is designed to check whether the given number is prime or not. If the given input is a prime number, then this second text box displays prime. If the given number is not prime, the result will be not prime. So the code required for this application is added into the procedure of button 1. Click. So here we have 4 variables n, I, r and flag. I is initialized to 2 and flag is initialized to 0. So in this program, to check whether the number is prime or not, the given number is divided by the number 2 to n-1, 1 by 1, and if we found that the number is divisible by some number in this range, that is 2 to n-1, then that number is not prime. If the number is not divisible by any of the number from 2 to n-1, then we display it as a prime number. So this is done with the help of these statements. First, the given number is stored into the variable n. So this n is divided by the number 2 to n-1, 1 by 1, and here the remainder is calculated by using mod. So first, suppose the input is 9. 9 is first divided by 2 and it checks whether it is divisible by 2 by checking the remainder. If remainder is 0, the flag is set to 1. If it is not divisible by 2, it goes for next I, that is I is equal to 3, next number. It divides 9 by 3. Remainder is calculated and it is checked. If remainder is 0, flag is set to 1. Otherwise, flag remains 0. This process continues up to n-1. After the loop is terminated, the flag value is checked, whether it has remained 0 or it is changed to 1. It has remained 0, it means that number is not divisible by any number in this range 2 to n minus 1. So in that case the result will be prime. Else, if the flag value has got changed to 1, that means the number is divisible by some number other than 1 and itself. In that case, we display the output as not a prime. So this is the code we require to check whether the number is prime or not. So let me show you one more method how this program or application is executed stepwise. First, let us change the startup form by going to become sem5 properties. Startup form we can select as prime. Click on start debugging. If the number given is 7, it displays prime. If the given number is 12, it is divisible by many numbers in the range 2 to 11, so it displays not a prime. When user clicks on exit, the application is closed. So let us execute this program stepwise. For stepwise execution, we use debug step into, or the shortcut key used is F8. Let me give the same number which we have already used, that is 7. So stepwise it shows the execution. I is initialized to 2 first, n is 7, so first it calculates 7 mod 2, which is 1, which will be stored in R. If we place the cursor over that variable, it shows the value R is equal to 1 now. So here the condition is false, it goes to next I value becomes 3, so it calculates 7 mod 3, again it is 1, so condition is false, it goes to next I, like this it continues up to I equal to 6. So in this case the flag value has remained 0, as 7 is not divisible by any number from 2 to 6. It displays prime. This is how it checks whether the number is prime or not. Let us take one more example. Let us take the number as 9. So here in this case, first I is initialized to 2, it calculates 9 mod 2, which is 1, which is not 0, so it goes to next I. Now I value has become 3, it calculates 9 mod 3. In this case the remainder is 0, as 9 is divisible by 3. As the condition is true, it has to set the flag to 1. So this will be continued for 2 to 8. Once it comes out of the loop, it checks the flag value. Now in case of 9, the flag has changed to 1, so it goes to else and it displays the number is not a prime. And we have the output here, result not a prime.